Hi everyone, this is Cassidy. Today we're going to be talking about solutions. Okay, so first of all, what is a solution? So a solution is a homogeneous mixture of two or more pure substances. Now, the first thing that I kind of get confused is what is homogeneous? So homogeneous is a mixture that has a uniform composition. So if you were to look at it, it might be made out of two or more substances, but you can't tell. For example, let's say you put some Kool-Aid powder in water. That's made up of two things, right? You have Kool-Aid powder and water. When you mix it together, it just looks like one thing. So that would be an example of a solution because it has that homogeneous mixture. So it's important to understand the difference between a solute and a solvent. So when you have a solute and a solvent, you make up a solution. A solute is what is being dissolved. In our Kool-Aid example, that would be the powder. Our solvent, on the other hand, is what is doing the dissolving. That would be the water. So for example, what if we made salt water? What if we had some salt and water? Take a second to think about that. What would be our solute and what would be our solvent? Okay, so our salt is what is being dissolved. So that would be our solute. And the water is doing the dissolving. So that's the solvent. A little trick, most of the time, your solid is the solute and the liquid is the solvent. But do make sure to ask yourself those questions. So when we make these solutions, it happens by a process called dissolution, which is just dissolving. Now, this is a three-step process. The first step, we have to break solute-solute interactions. In the second step, we break solvent-solvent interactions. And in the last step, we form solvent-solute interactions, okay? So we're gonna go more into depth into each of these steps and what that means. So our first step is to break solute-solute interactions. So for example, let's say our solute is salt, right? It's sodium and chlorine. When they come together, they make salt. Now we have to break those interactions holding the salt and the chlorine together. When we break that interaction, technically it is still salt, right? So when we break that interaction, we are left up with the sodium ion, which is positive, and our chlorine ion, which is negative. Okay? This process is endothermic. Okay? We're going to go more in depth into what is endothermic, but for now, I want you to know that when we do step one, we have an endothermic reaction. An endothermic reaction needs energy to happen, and the delta H value is positive. Delta H is enthalpy, which you can just think about as energy, right? So if the solution needs energy, our energy value is positive. Second step, breaking solvent-solvent interactions. Let's say we have our water as our solvent, right? So our water is connected by these hydrogen bonds between the two molecules. So in this step, what we want to do is we want to break those hydrogen bonds. When we break those hydrogen bonds, we still have water, right? But now we created a dipole. So if you can see, wonder if I don't know if I can do a little arrow, but if you can see, we have a positive charge near our hydrogen and a negative charge near our oxygen because that oxygen is pulling those electrons towards itself. So this is also an endothermic reaction, okay? It needs energy and the delta H value is greater than 0. Now, step number 3 is the different one. We're forming solute-solvent interactions. So let's take our salt particles that have now been broken up into their ions, and let's take our free floating water molecules. When we form these interactions, the positive salt ion is going to line up with the negative oxygen, and the negative chloride ion lines up with the positive hydrogen, and they form those bonds, right? Now, normally with dissolution, I didn't draw this out, but normally you get so many water molecules surrounding the sodium and chlorine that they're kind of encapsulated by water. In this case, I just show them interacting with one. Now, the forming the solute-solvent interactions, this is an exothermic process. In an exothermic process, we are releasing energy in our system, which means delta H is less than 0. Energy is going away, so that value is negative. Okay, So exothermic and endothermic, you could just memorize that the first two steps are endothermic and the last is exothermic, but I want you to actually understand that, okay? So I'm going to give you a little mnemonic to help you. Barb, bonds are breaking, right? If you do BARB, that kind of spells out bonds are breaking. So let's think of barbed wire. When you think of barbed wire, that's something that can go in, right? If you try and hop a barbed wire fence, you're probably going to get some scratches or have some barbed wire poking into you. When you think of the word endo, you can think about it going in, right? Endo, it's going in. So an endothermic reaction is when bonds are breaking and the enthalpy is going in, okay? So barb stands for bonds are breaking, which would be the very first step, right? And it also shows us that our energy has to be positive because our energy is going into the system. Now, the other end of the story is barf. Bonds are forming. Okay? You can think of that as someone just obviously throwing up. When we think about this, think about exo, right? X means it's going out, exit, it's going out, like throw up. So you can think of barf, bonds are forming. And again, the energy is leaving the system, so that energy is negative.